the wood that withstands 100 miles per hour. It is a clash of physics that lasts less than a millisecond. A 5-ounce leather ball, traveling at 100 miles per hour, strikes a piece of wood with enough force to shatter bone. Yet, the wood doesn't just survive, it propels the ball 100 meters into the stands. This is the miracle of the cricket bat. But don't let the traditional look fool you. A modern professional bat isn't just a shaped plank. It is a highly engineered energy transfer device to create a tool that can withstand thousands of high-velocity impacts while remaining light enough to swing with a flick of the wrist. Factories must combine 200-year-old seasoning techniques with massive hydraulic power. Today, on Process Sector, we are going inside the factory to see how raw willow logs are transformed into the world's most powerful cricket bats. The supply chain. The English Willow monopoly. Every elite cricket bat in the world, whether it's used by Virat Kohli in India or Ben Stokes in England, starts in the same place, the wet, marshy ground of the United Kingdom. Specifically, they come from a tree called Salix Alba Caerulea, or English cricket bat willow. Why this specific tree? It's all about the process sector of biology. This willow grows incredibly fast, creating a wood that is porous, lightweight, and filled with tiny air pockets that act like natural springs. Unlike Kashmir willow, which is denser and drier, English willow provides the ping that professionals demand. Suppliers like J.S. Wright & Sons have been the gatekeepers of this raw material for over 125 years, planting over 30,000 trees annually to keep up with a global demand of nearly 1 million bats per year. From logs to cleaves, the raw preparation, splitting and sawing. The industrial journey begins when the willow logs, usually 15 to 20 years old, arrive at the milling facility. They are cross-cut into rounds about 28 inches long. Instead of using a circular saw to cut the rounds into planks, workers use a traditional splitting method. By driving a wedge into the center, the wood splits along its natural grain. This is critical. If you saw through the grain, you weaken the bat structure, leading to snaps during high-speed play. These rough split pieces are called clefts. They are then put through a twin-edger saw to create a flat face and a triangular back. At this stage, they look like oversized wedges of cheese. The seasoning and waxing. A raw cleft is 50% water. If you made a bat now, it would be heavy and prone to rot. The clefts move into the drying phase. First, the ends are dipped in hot wax. Why the wax? This prevents the moisture from escaping too quickly through the ends, which would cause the wood to check or crack. The clefts are then stacked in kilns or open-air sheds for 6 to 12 months. In modern factories, moisture meters are used to ensure the wood reaches exactly 10% to 12% moisture content. Too dry, and the bat becomes brittle. Too wet, and it lacks power. This is the longest part of the process sector, where time is the primary tool. The hydraulic knock, compressing the willow, grading the wood. Once seasoned, the clefts are graded. Grade 1 willow has straight, even grains, the vertical lines on the bat, and no blemishes. Grade 4 might have butterfly stains or knots. While a Grade 4 bat is often just as strong, the market demands the clean look of Grade 1 for premium prices. Next comes the most vital industrial step: pressing. Willow is naturally soft. If you hit a ball with raw willow, it would leave a deep dent. To solve this, the factory uses a hydraulic press capable of applying 2,000 to 4,000 psi. The cleft is passed under a heavy stainless steel roller multiple times. This collapses the soft wood fibers and knits them together, creating a hard, springy surface. It's a delicate balance. Press it too much and you lose the ping. Press it too little and the bat will break. The handle and the V-splice. While the blade is being pressed, the handle is made separately. A cricket bat handle isn't just one piece of wood. It's a spring system made of cane and rubber. Factories import Sarawak cane from Malaysia, slice it into strips, and laminate them back together with rubber strips in between. This prevents the sting from traveling into the batsman's hands. The blade is then put into a splicing machine, which cuts a deep, precision V into the top. The handle is coated in industrial adhesive and hammered into the V with a hydraulic ram. This joint, the V-splice, must be perfect. It is the point of highest stress when a player hits a 6. Shaping the beast, CNC versus the ADSI. The CNC carver in mass production factories like SS, SG, or Gray Nichols, the rough shaping is done by a CNC, computer numerical control machine. A digital blueprint of the bat profile is loaded. The machine's spinning blades carve the scallops, the hollowed out parts, and the spine of the bat in under 2 minutes. However, for pro-grade bats, a master pod shaver still uses a traditional adze and draw knife. They listen to the wood by tapping it with a mallet, removing a few grams of wood from specific areas to perfectly balance the bat. This is where the process sector meets artistry. Sanding, binding, and finishing. The bat then moves to the sanding drums. It goes through 4 stages of sanding, from 40 grit to a fine 400 grit, until it feels like silk. Next is binding. A machine spins the handle while a high-tension nylon thread is wrapped tightly around it. This provides extra strength to the splice and a grip for the player. Finally, the bat is polished on a horsehair buffer. The friction creates heat, which draws the natural oils to the surface, creating a glossy, professional finish without the need for chemical varnish. Testing the sweet spot. The final inspection. Before the stickers are applied, the bat undergoes a ping test. A specialist drops a high-grade cricket ball onto the face of the bat. They aren't looking for how high it bounces, but for the sound. A high-pitched "talk" means the wood is tight and ready. A dull thud means it needs more pressing. The final stickers aren't just for branding. They are often thick, anti-scuff sheets that protect the wood from moisture and surface cracks. The bat is weighed, gripped with a rubber sleeve, and shrink-wrapped for its journey to a sports shop halfway across the world. Conclusion: a masterpiece of physics. The process sector. Final word: the journey of a cricket bat is one of the most unique in all of manufacturing. It starts as a thirsty tree in an English swamp, survives a year of seasoning, is crushed by thousands of pounds of hydraulic pressure, and is finally carved into a precision weapon. It is the only sport where the equipment matures. The more you hit it, the better the fibers become, until it reaches its peak performance. So, are you a fan of the massive, thick-edged bats used in T20? Or do you prefer the classic balanced profile of a traditional test bat? And did you know that the ping was actually engineered into the wood? Let us know in the comments. If you found this deep dive into the process sector fascinating, don't forget to hit the like button and subscribe. We're going from the cricket pitch to the high seas in our next video. You won't want to miss how giant steel anchors are forged.